Welcome back everyone. In this video we'll dive deeper into list slicing in Python. We'll explore more advanced techniques and use cases for slicing lists effectively. Before we dive into advanced list slicing, let's do a quick recap of basic list slicing covered in our previous video. Basic list slicing allows us to extract a sublist from a list by specifying start and end indices. Here's an example of basic list slicing. We could set fruits equal to banana, apple, strawberry, pineapple, and grape. Now down here, we can say sublist is equal to fruits 1 up to 4. And if we print sublist, we will get apple, strawberry, and pineapple. This is because we're starting at index 1. So remember, the first item in the list is index 0. So we start at index 1, which is apple, and then we go up to, but not including 4, which is the 5th item. So grape. So we only get apple, strawberry, and pineapple because it doesn't include 4. It includes 1, but not 4. So now let's explore more advanced list slicing techniques that can make your code more concise and efficient. By adding a third parameter called the step, we can control the spacing between the selected elements. To do so, we add another colon. So I have this list over here with 10 different fruits in it. By the way, if you ever are in a list, you can actually create a new line if it goes off of the page, so you don't have to scroll. Just after a comma, just enter, and then you'll be able to have it on multiple lines. Python will read it the same way. But anyway, we can set sublist equal to fruits. Start at 1, stop before 9, and then we add a second colon and type our step, so we're going to do 2. So when we print sublist, you get apple, pineapple, watermelon, and raspberry. This is because we go from 1, which is apple. We stop before getting to 9, which is the last one. So right now we've got all these. But now we go by a step of 2, which means that we get every other one. So we get this, we get this, we get this, and this. And the reason we don't get this one, like I said, is simply because of the fact that we stop before getting to 9. If we had this empty over here, it would be 1 onward, like I showed you in the previous video, and then it would go by a step of 2. So that would include peach. But we have a 9, so it stops before getting to it. So that's why we get this. Did you know that you can use negative indices for list slicing? This is another way to reverse a list. The other way was shown in the previous video, where we used the .reverse method. Negative indices count from the end of the list, allowing us to perform reversed slicing. So here's an example of reversed list slicing. So we could set sublist equal to fruits, and then 2 colons, and then a -1. So this is essentially saying, well, we don't want to specify a start or end, so remember doing this would just be the entire list, because we're not specifying a start or end. So we don't want to specify a start or end, which means we want everything, and then we go by a step of -1. If we didn't want to go by a step, we would just not type a step here. That's because the default step is just 1. But if we want to specify it, we just add another colon and do -1. You would not do this. This would be completely different. You just do 2 colons and -1 to reverse the list. And so if we were to print sublist, we get everything reversed. So you see how it starts with peach at the end, and it goes reversed. So that's the reversed list. List slicing can also be used to create a copy of a list. Let's explore the difference between assigning a variable to a list variable and assigning a variable to a copied list. So here's what I mean by that. So let's just, I only have 5 here, because we don't need all these ones for this example. And so in here, we could do a full list slicing. So to copy the list with slicing, we could just do copy 1. And this is the first copy, which we'll do fruits, and then referencing all indices. We could just print copy 1. And as you might expect, it's everything in the list because we just copied it with every one of these. Now we can set copy 2 just equal to fruits. And as you remember, if we had a variable equal to a string, and then we set var2 equal to var, it would equal string, right? Well, over here, we're doing that same type of thing. We're not referencing any index. We're just setting it equal to this list. And this is creating, these two are completely different. This one is copying the items in the list, and this one is creating a reference. And you'll see what I mean after I show you this example. So As you can see, we're printing copy 1 and copy 2, and so that looks completely fine. They're both exactly the same. But now, if we were to change fruits, the first item, and we set this one equal to a watermelon, now this would just be watermelon. That's what it would be once we change that one. So once we set this, and now we can print the original list, and then we can print copy 1, and then copy 2. And these will be different. So, after we print this, I'm just going to put another print statement to separate them. Okay, so before we edited the first item, they were the same. Copy 1 was this, and this was copy 2. Now, after we edited it, obviously, this is the original list. The original list was changed. Copy 1 was not changed, and copy 2 was changed. This is because in copy 1, we copied all of the items just in place. We just took all the indices and copied them into here. But with copy 2, we actually created a reference. So when we edit the original list, the reference also gets edited as well, because it's just referencing back to this original list here. So if you want the kind of behavior where you want to copy every item in a list, and if you change the original one, it doesn't get edited, do what I have here. But if you want a reference that changes along with it, then copy this one. It all depends on what you're doing. Congratulations, you've now learned how to do more advanced list slicing techniques in Python. Advanced list slicing allows you to extract, modify, and manipulate list elements with precision and flexibility. By incorporating these techniques into your code, you can make your programs more concise and efficient.